Hello guys. Soon we're going to begin using Fulcrum to plan and schedule and keep track of everything that we do in our system. Each one of you or the workstation that you work within is going to be issued a tablet, and each of you will have login credentials. I'm going to log into this one as Luis. If you open your tablet and you see this screen, you'll have a PIN, a 5-digit number that you'll enter here and then click Login. But if you didn't sign out the day before, which you don't have to do, you will just automatically be on this screen. This screen is set up specifically for Luis. It shows jobs that are going in the Haas or the big mill or the second big mill, because Luis sometimes runs that machine. You'll see here that on September 15th, there's 1, 2, 3, 4 jobs that are scheduled for Luis to work on. This one shows pending, and that's probably because whoever's working on these parts before him hasn't finished them. So this job hasn't gotten to him yet, so it shows pending, as opposed to this job, which says ready. And that means that the material is available, and if there were any processes done before this, like the lathe work for example, they've already been completed, so this job is ready for Luis to log into. You'd always want to choose the highest job on the list that says that it's ready and log into that one first. After you've completed that, it will disappear from the list and you'll log into the next one that shows ready. So let's go ahead and log into this particular operation. On this screen, we can see the part number for the part that he's going to be machining, 140-0021-0110. It's for job number 38654, and he's going to do it in the big mill. This was scheduled to be done in big mill number 1, so that's where he should do it, but you do have discretion to use big mill number 2, for example, in this case. This box is telling you that the job previous to this, which was turn medium, meaning in one of the medium-sized lathes, where the four-jaw work was done on this particular cap, that has been completed. So there's 3 units that you need to collect from there. They will probably be moved to your station by Brian when the previous step is completed, but he'll work that out with you guys as to who's going to move what, where, and when, what the sequence of events will be. But at any rate, whether they're already at the workstation or Luis had to go and get them from somewhere or ask someone to bring them to him, he has to indicate that he has collected them from the previous step, which was turn. Once you've collected the parts, you can click the details box, and you can see here the job number, the machine it's going to be done in, the due date for the job. That's not the date that this particular operation is going to be done. That was scheduled for today. But this just gives you an idea of when this total job, when all the operations are done, when it's due to the customer. Number for the part, description, the machine it can be done in. This says mill big. There's big mill number 1 and big mill number 2. This is not specific as to which one. That choice gets made when the scheduler, which automatically schedules all the work, sees where there's an opening on a particular day for the amount of time needed to do the job, and it schedules it there. It might have put it in big mill 1 or it might have put it in big mill 2. The instructions for this operation are tap the tie rod holes. Planned quantity, 3 pieces. We can see here that this job is for Watson Hydraulics, and the sales order number is 1015. So let's close the detail box, and we'll look at this bar at the top. What this is telling us is that the setup might take 30 minutes. It's just an estimate at this point. We don't know for sure how long the setup is for this particular operation, but we're going to find out, because when Luis is ready to start the setup, he'll be sure this box is clicked to turn it black, and then he clicks the play button or the start button, and the counter will start counting up. It's keeping track of how much time he spends on the setup. We may find out that he sets his job up in 9 minutes or 42 minutes. Whatever it turns out to be, it's going to be collected by Fulcrum, because when he's done with the setup, he's going to click the pause button, and whatever amount of time the timer ran for will be recorded in the system as how long that setup took. Now that the setup is complete, he's going to click labor, which means run the rest of the parts, and he's going to click the start button again. This is a different timer. It started from 0, and it's indicating that we expect the 3 pieces that he's going to make to take 36 minutes, or roughly 12 minutes apiece. So you let that timer run, and when he's finished all 3 pieces, he can pause, and he can go over here and mark the job complete. These boxes show number of units done, 3 out of 3. That would be typical, that you did all the parts that needed to be done, and you'd click complete. If any had been scrapped, you would enter a number here. 1 piece was scrapped, and this drop-down box, which doesn't show anything at this time, but I will populate this with various reasons, like broke a tool, or made a mistake in the program, or whatever happened. You'll have choices here, so you can indicate why something was scrapped. And in that case, you might say 1 was scrapped and only 2 were completed. So the system would have to deal with that by scheduling the production of 1 more piece when material was available to do it. But in this case, we're going to say that 3 out of 3 pieces were complete. Click complete, and now that operation is done. It says here, operation was completed by Luis on 9/15. We could reopen the operation if we wanted to change something, if we'd made a mistake or some reason needed to go back and work on some detail of it again, and you could restart the timer and it would add additional time. It's telling us here that the next operation is also in the big mill. So clicking that moves on to that job. We're not completing it yet, so we're going to close that. We will collect the pieces, even though they're the same parts. If they had come from another workstation, this would be even more important, but what we're indicating here is that these parts have moved on from the last process that he did to this process. So collect. And what is the next process? Open the details box, and it tells us we're going to put the ports in. So setup is turned on, start the timer, and the setup begins. When the setup is finished, click pause, then click labor, and start the timer again, and it will keep track of how much time is spent to actually run all 3 pieces. A lot of times, one of the parts is completely done by the time you finish the setup. That's all right. We're still keeping track of everything, setup time and cycle time, to finish the whole batch of 3 pieces. That information is super useful because Fulcrum will use that, knowing how long it will take to make 3 pieces. The next time we're going to do a job of that same item for whatever quantity, it will divide the setup time over the number of pieces and add the cycle time for each piece to come up with a total block of time, and it'll use that to decide where this will fit in the schedule and in what machine it would be done in when we run the job. So in other words, it will use real-time data for how long things actually take, not just my guess as to how long they should take or Brian's guess, but we'll be recording actual time so that we can accurately schedule the workload in each workstation or each machine going forward. It'll also help us to understand how much it costs us to make a particular product, a part or a complete cylinder, and we can use that information to price the product to the customer at the right price level so that we know we're making profit and not losing money. On the other hand, we'll know that we're not charging too much money, because if we're charging too much, we may not get the job. Somebody else might have a more competitive price. So once the labor is done on all 3 pieces, he clicks the pause button again, and he comes over here and he indicates this job is complete. Now the next operation is also in the big mill. Let's find out what that is. If we move on to that operation, turn off the complete button and open details, we see that he needs to cushion these caps. So we're going to again collect the 3 pieces because they're arriving at this operation, which happens to be at the same machine, but it might not be. Once we've collected them, we turn on setup and start, and the setup timer starts to count. When we're done with the setup, we hit pause and then click labor, and when we start making the remainder of the parts, we start the timer again. Timer's counting up. Now, I did skip one step, and this step will most often be done by whichever workstation handles the parts first, which in a lot of cases is the saw. When the saw is going to cut the material, they need to pick the material from wherever it's going to come from. Now, this is an unusual example because this part number with the 21 in it means that this is an MP1 cap. So that is going to require, each one is going to need one of these blocks that's 1 1/4 by 4.5 square, and it's going to need 2 pieces of MP1-07 tine. So to do this particular operation, all we're going to be working on are the blocks. We are not doing anything with the MP1-07 tines. So I'm going to put 3 in this box to indicate that I've grabbed those 3 pieces of material. They may already be on my cart, or they may have come, they may need to come from some other place, whether it was the machine that the parts were made in previously, like the lathe, or maybe the saw cutting department cut them and they need to come to my station. Brian and you guys will work out who will actually move things from one place to the next, but at some point in the process of this part, they need to be picked, and the reason is that Fulcrum keeps track of how many pieces we have on hand. This raw block that we buy from BD, we currently have 7 pieces on hand, and we're going to use 3 of them for this job. So this moment when we indicate that we're picking 3 is the point at which 3 gets deducted from how many we have on hand. Now the system knows we only have 4 of those. The next time we have a job that requires this block, if, for example, we needed 10 of these, Fulcrum would tell me or Brian or Mike, whoever's in the system entering production info, hey, you need 10 for the job, but you only have 4, so you should order 6 more. Or whatever your normal quantity you order is, might be 20, might be 50, whatever it is, it will suggest that that purchase be made because this job will not be able to be completed without enough of these blocks. And we'll know that right at the beginning. But that information is only going to be accurate as long as people remember to pick the material for the job that they're working on. We did not click pick all in this case because we're not going to pick these MP1-07 tines. That's going to happen when the blocks and the tines are all supposed to be at the welding station. So when Caesar goes to log in the welding department to this job for welding the tines to the blocks, that's when he'll pick these MP1-07 tines. So, turn pick off. We've been progressing here, machining the parts, and we're going to imagine that we've had enough time to do all 3. We pause the timer. We click complete. This says 3 units done out of 3 units. Complete. Now the next process is post-process, which is not something Luis is going to do. So he's not going to open this process. He's just going to close the complete box, and then he's going to go up here where he sees his initials, and he's going to click the back button, and that'll take him back to the page that shows him the jobs that are scheduled to come through his machine. You'll notice that the one that we just worked on is no longer on this list. It's finished. Fulcrum's closed it out, and that piece of or group of material has moved to the next workstation, post-processing in this case, for the person at that station to do that work, deburring, washing, whatever needs to happen there, before it moves on to the welding station, where Caesar would work on the parts. So Luis looks at his list. It's still September 15th, and the next thing he's going to do is run some 320 P1 pistons. He's going to make 7 of these. Now, we might need 7 for a job, but Brian might have decided we're going to run 27, so we'll have 20 for the shelf. If that were the case, this would say we're going to run 20 or 27, whatever it was that he decided. We also have a situation here where this job is pending. I can't start this job because whatever's supposed to happen before this step, and this step, since it's in the mill and it's an iron piston, is putting the spanner wrench holes in, but apparently the person before me hasn't finished them, so I really can't log into this job. If I do, I don't have the material to collect. I can't collect the material if the person before me hasn't finished the work. So unfortunately, in my example here today, with such a small number of of examples loaded into the system to show you, we can't really proceed with this item because it's pending. It's not ready, so we can't click into it. If we look over here at, say, what would be a good example? Well, let's look at George. So George is supposed to do the lathe work on heads. Even though we're logged in as Luis, I'm going to go ahead and log into that job. Luis would never run the lathe to do this, but he can log into it if for some reason we decided, hey, Luis, step over here and run these parts. So in this case, here's the job number. This is the machine that the work's going to be done in, QTS 250. It's a head, and it says do the face groove side. So we're going to start the setup, and the timer will begin counting. Now, this area of the screen has like a logo on it, but as I get drawings collected together for all the different parts, they will be attached to this particular item, and they'll follow it all the way through production, and you'll actually see a drawing right here on the screen that ideally we won't need a paper copy on the shop floor at all, because you'll just be able to see it right on your tablet. You can use that for programming, or notes may be included on it telling you what program number, what tools to use, the sorts of things that you used to jot down on the drawings. Some of them will have that added, but if they don't, you can open this notes box and you can add notes here. Now you can say program number 14010 or whatever the program is that you're going to load to run this. You can attach it right here. You click send, but it doesn't really go to anybody. In this case, we're just adding a note so that when you do run this job, if you open this in the future, it's going to tell you, hey, call up program 141010, and you'll have the right program in the machine to do the job. So turn the notes box off, pause the setup, move on to the labor portion, and start that timer. And when we have all 30 pieces done, you notice we have 3 hours allotted to do 30 pieces. That may be an accurate number, it may not, but we'll find out. When these parts are run through the lathe and they're complete, we'll know how long it really took to run 30 pieces. So let's suppose we're approaching the 3-hour mark and we click pause. We go over to the complete box and we say 30 pieces were finished, complete. The next operation is turned medium, which is the other side of the block. We just did the face groove side. So we can move on to that operation since it's the same machine that's going to do the work, but we still have to collect the 30 pieces as if they've come from somewhere else. They came from the other side of the cart. Click setup, start the timer. By the way, let's look at details. What are we doing here? Oh, we're doing the counterbore side or the gland side of this head. So we're working on the setup. We finish the setup, so we pause the timer and we move on to actually making the rest of the 30 pieces, and we start the timer. And after we approach the 2-hour mark, or however long it takes, it might be an hour, it might be 5 hours. I don't know for sure. We'll have to find out. Then we pause, complete button, 30 pieces got done, complete. Now this tells us, hey, the big mill has another operation to do. Would you like to open that? Yep, I'm going to do that because that's the machine I'm working on. What am I going to be doing? Oh, R1000 pattern and tie rod holes through. All right, collect the 30 pieces, start the setup. As soon as we're done with the setup, pause, move on to the actual run, start the timer. So now we've finished our 30 pieces. We stop the timer. We go to complete. 30 pieces are completed. Next operation, big mill again. They're going to need to be cushioned. That's what it is. So we look at details, cushion, just like I thought. Collect 30 pieces. Start the setup timer. As soon as we finish the setup, we stop the timer, click labor, start the timer again. When we've finished all 30 pieces, we stop the timer. And notice this is 5 hours to do this work. 5 hours to do 30 pieces. That seems like way too long. Maybe it's right, maybe it's not. But after whatever amount of time it really takes, we click complete. And now we've captured reality of how long it really takes to do those processes. I'm not going to click post-process because Luis isn't going to go over and wash and deburr these parts. So we'll go back to his tracking by clicking back to this page. Oh, that's right, we were on George. We weren't even on Luis. How did we end up like that? Well, here we go. So the only job left for today for Luis is pending. He can't start it, so he's going to have to find something else to do. Anyway, that's just a quick example of how Fulcrum works and what you'll be doing in order to log in and out of setups and jobs and picking material and indicating things have been complete so the system keeps track of everything. If you have any questions, let me know. Thanks. Bye-bye.